Yeah, so question 9 here is a nice little applied maths type question. Some of them appear quite a bit now. Just they like to put in practical ones. So like the one with the crank at the end of a belt, and this one is kind of an applied mathsy type one, relative motion, but very simple version of it. So two ships are asked the distance between them, and they're going in perpendicular directions, which makes it quite easy. So really the whole thing just converges on, because it's perpendicular directions, converges on, so the distance between them here is d, and you just get Pythagoras equation for it. Now, one is going twice as fast as the other, b is going twice as fast as that. You're given that 90 is the original thing, so you know that the distance at any point is going to be 90 minus 15t there, because that's going to close an original gap, that whole original thing. So that's going to start at A and it's going to be at A dash here. That's originally B, that's going to go to B dash. That's going to be basically just distance is equal to speed by time, so it's going to be 30t, and that's going to be that's your distance. And but in this case it's just subtracting the distance that you're going is going to be, that's left is going to be 90 minus 15t. So basically your d there, find the distance between the two ships after 30 minutes, put in t. The trick there is just watch the units, so t is going to be a half. So remember your units, and there will always be at least one of them in the exam paper. So just, you're given kilometers per hour and then you're put in minutes, so just be aware that's half an hour. That's so definitely going to be at least one trap like that in the exam, so watch out for it. And if you haven't found it, then say, right, I've been snookered, basically I've been suckered, so where have I been suckered? And scan through the paper to find out where that is, because it's definitely going to happen. Okay, so just put in t as a half into that and you'll get it. All right, then t is the time after the ship sailed, show the distance given by blah blah blah. So basically that's just this. We're going to keep the general format now, and d squared is going to be equal to 30t squared plus 90 minus 15t all squared, and just work that out. D is equal to the root of that, then working all that out, and then you'll get that guy. Fairly straightforward. Use calculus to find the t when they're closest together and find the distance between the ships. So it's s of t, so d s of t dt is equal to, okay, so it's equal to, I suppose, we can just take it from what we were given the last time, because we're on the next part. We'll just take it from what they gave us. So it's equal to d of 1125 t squared, this is all bracketed, minus this guy t plus 8100 all to the power of a half. Okay, so to differentiate that, you use the chain rule. So the first step is everything there in brackets is now going to be to the power of minus a half. All right, and then we work inside the brackets, and then so multiply it, so everything there up there is going to be to the power of minus half, and then we differentiate inside then. So 2 by this guy is 2250 t minus just this guy 2700, and now we're setting that equals 0 for the to show so the distance between the ships at time t. Oh yeah, so to find the closer to each other, so the minimum distance is what we're trying to find. So we now have that equals 0. So those two products equal 0. Now, so that would mean that it's this blah 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 t minus 22270 equals 0, and then it's this underneath there, so it's this bit underneath here to the power of a half. So that kind of t squared minus blah 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 t plus this stuff. And the reason I'm not being too worried about that is because that guy is underneath the line, and we're only concerned with this. This is the one that has to be equal to 0, because that cannot be equal to 0, because if that was 0, the whole thing would be infinity and it would blow up. So it's that one that's 0. So we're left with this guy, 2250t minus 270 is equal to 0. So t is equal to 270 over 2250. And that'll be in hours. Okay. Okay, so find the value of t, and then and just shove that into t into the distance formula there that you got earlier to get the actual minimum distance. That's a fairly easy question, and that's a nice one if something like that came up. So that is fairly nice. So let's have a look at earlier section 8. Okay, some of the geometry bits. Okay, coordinates of the points are this, and this. Find the perpendicular distance from A to BC, and based on your answer, conclude about the relationship between points A and B and C. So I suppose the clue there is it's going to be a particularly unique relationship between A and B and C. Okay, so how would you do it? So B and C. So get the slope of the line from through B and C, and then get the equation of that line, and then use the distance formula from distance of a point from that line, and see what you get. So all of these, as you know, are in the log tables. So just be very familiar with those, the log tables equations for the line. Make them the Bible. So coordinate geometry of the line. So slope formula, you're going to be using that all the time. The distance formula, yeah, you're using that all the time. Midpoint, not as much. And then you have the form of a line given you have the slope and 1 point, or then the form of a line given you have the slope and just the y-intercept. Area of a triangle, and then point dividing in a ratio. That does come up sometimes. And then the distance of a point to a line. So that's the one you'd use there. The slope of angles between two lines of different, the angle, tan of the angle, between two lines. So just be aware, one is going to be an acute angle, one is going to be an obtuse angle, and then circle ones. So okay, so I think that's a fairly straightforward enough question. So let's just have a look at it, what they give there. That is fairly straightforward. Okay, so perpendicular distance, so the slope of the line and the perpendicular distance is equal to 0. So if the perpendicular distance of A to the line BC is 0, then it has to mean that there's no distance between A and the line BC. In fact, A is on that line BC. So they're all on the same line, and that's a fancy word. Colinear is a fancy word for them all being on the same line. Grand. So that's a nice one. A little bit quirky, but it's a nice one nonetheless. Okay, equation, the acute angle is theta, next angle is 60 degrees, and find the angle of theta. Okay, so here now it's going to be straightforward enough. It's okay, so you're given the slope of alpha. So you've given that is, so, well, you're not given it, you can find it, because just express that in the terms of y is equal to mx plus c. So you get y is equal to a half times x, so the slope is a half. Okay, so the slope of that angle there is a half. Okay, and the slope of b then is equal to tan 60. So we have those, and then we can get the angle of the intersection of those, slope between two lines, using that formula which you saw earlier. Just tan theta is equal to plus or minus m1 minus m2 over 1 plus m1 plus m2. Now they also have an easier way down there, where they're saying just add all the angles together and you get 180. So what that's saying is that that angle plus that angle should be equal to 180. It's a straight line. So what is that? Well, it's equal to, if you draw a horizontal line there, then by opposite angles, that the angle that makes with the horizontal angle is going to be that angle there. So it's going to be arctan of a half. So it's going to be the slope of that line, basically. So the horizontal line. So we know that. So that bit there with the horizontal. Then the angle then underneath it is going to be 120, because those have to add to 180. So if you have, draw another diagram of it here. So we have that as theta. So we're saying if we draw a horizontal line there, then that's going to be arctan a half, because it's the slope of that line here. That's 60, which means that has to be 120. So basically the three angles have to sum to 180. So that plus that plus that is 180, which then means we can find theta. Kind of nice and easy there, which is a nice way of finding it. It's a shortcut, I suppose, but equally valid. Okay, circle. Yeah, so this guy, yeah, okay, tangent to the circle. You would be drawing with a compass here, so it wouldn't be as horrific as this, but I'm short on time. You won't be. That's A, and that's B, which you're given, which is 5/8. You are given that circle there, so very easily find the center. So the center is plus 2 minus 1. Plus 2 minus 1. T we don't know yet. Find BT. Okay, so we need to find BT. We know that because that is a tangent, that's going to be perpendicular to that radius. And we can find out that radius as well, because r is equal to the square root of g squared plus f squared minus c, which is equal to square root of 2 plus 1, and what's c? Sorry, 2 squared plus 1 squared plus 4. Yeah, so that is equal to the square root of 9, which is equal to 3. So the radius is equal to 3. So that's 3. So then we got a nice Pythagoras there. We've got a right angle triangle. So in order to get BT, we can just use Pythagoras then. So BT squared is equal to the r squared, which we now know is going to be 3 squared, plus the length of that line. So AB squared. And we can find AB squared using the distance formula. So that's fairly straightforward. Now, I suppose the thing is to remember that that's the connection there, that radius is perpendicular. And at first, that didn't click with me. So what I did was I used the formula, and it's equally valid using a different way. I used the formula of, in the log tables, which is the formula, they give you the formula for a tangent of a line at a point. And where's that? The tangent of a line to a circle. So, and here we are. So that's the tangent to that circle is that, or else if you're expressing it the other way, the tangent is this. So you probably use that one there. So then you get the formula for that line. Probably a bit more roundabout, but it's equally valid. So you now have the equation of that. You now can use the log tables to find the equation of that line tangent to a circle, given the center and radius. Now you don't know that point, so you have to put in x1, y1 for that. Then you put in the fact that that's an element of the line, and that gives you another thing for that. And you have simultaneous equations, and you can work it out that way. Lot longer, but it's still valid, that method. Wouldn't recommend it over the other one because the other one's a lot easier. Okay, so this one, two circles lie on the x-axis. So you know that their center is going to be whatever x1, 0 and x2, 0. The radius are both 5, and a point is on each of them. So you're not told anything about it. Because I'm holding the phone, the lines are even worse than normal, given you're not told anything about the intersection, so you just kind of have to assume it's 2. Well, it doesn't really matter. So that's your 0.14. That's your center 1, center 2, which are actually on the line on the x-axis. So they both have a radius of 5. Find the equation. So that's reasonably straightforward as well. Yeah, so you have that was the one that we looked at earlier. So this one, you only have an x coordinate for, well, you have an x coordinate, 0 for the centers of them, and you know that you just put them into the standard equation for a circle and solve simultaneous equations. All right. Okay, yeah, so this guy just takes a little bit of tweaking around. This one.